So we have another 2024 12A problems. So this was number 16. It's also another classic distribution problems when you have some number of like kind of balls and boxes problem type. So the question says we have like 12 tokens, three red, two white, and one blue, as well as six black. And we are going to distribute these into three players. Each player will get four tokens, and we want to find the probability that the some players gets all the red ones, and our player gets all the white ones, and remaining player gets the blue tokens. Is the probability we are looking for. So the first things first, like let's kind of make a bit visual. So I'm gonna say, let's assume we have three individual, right? Because organizing kind of give us a bit better way to approach the problem. So the first person, let's assume person A, and the second person is B, and the next person, let's say this is C. So at first, I'm gonna just kind of organize in this orders because when you kind of swap these individuals, you will get different arrangements. So let's assume the person A will be getting the all the red ones. So which means we are gonna have three red, but this has three now. We just need like one more, and then that will be coming from the black one because we are told the red one should be taken by one person, and the white ones, which is like two white, will be taken by the another person, and the remaining ones will be getting for by the person C. But the person A should have one more, and the person B should have two more. But the person A cannot get white or blue because we are told that should be just the red one. And then since we are going to have six blacks, we need one black for this person as well. Okay, and the same reasoning. So person B should have all the white ones. Okay, but the blue and the other remaining one should go to the third person, which means the second person cannot get blue. So which means the second person get two more black. And that's going to be the person B. And then the last person should have one blue and three black. So the question is now kind of a bit clear, but the problem is how we actually can do this probability. Like even denominator, like a bit interesting because if you just try like saying like 12 choose 4 and then 8 choose 4 and 4 choose 4, that doesn't really give us what we want because the order of those like fours, like when you say like 12 choose 4, you mean what for? So which kind of like matter, right? So which is why instead of doing that way, I'm just gonna a little bit do it differently. So the first thing is let's assume we are trying to find the numerator. So the numerator is just we want to find three red and one black, right? So and just imagine you have 12 tokens like listed in a row, and you just want the left fours are three red and one black, and then that will be the tokens by taken by the person A. So like, I'm not sure, like just imagine we have like three, maybe I should be coloring this. So I'm gonna say this is 1, 2, 3 red, and then we should have one black. So just imagine this is the person A, and the second person will get two white and then two black. So, and then the last person will get one blue and two black. So the one blue and then three black. So that should be like 1, 2, 3. But the problem is, you know, these three reds, I just didn't want to do the middle one because of the white. So like these three can be swapped as well. Like this, like I mean, four of these. This, the black one could be this one, could be this one, could be this one. So we have four different ways. We actually can get three red and one black. So you just imagine the like arrangement of like some letters, like three R's and one black. So that's just the same thing. So which is why getting this arrangement for the person A, when you have like three red and one black, is just four ways. So let's write that. And then the same idea, we have 2 white and 2 black for the middle person, like which is in this case B. So you can have like a 4 factorial. I can just maybe write it even this way. If they were all different, so but we have 2 whites, which has to be divided by 2, and then divided by 2. And for this guy, so you can say 4 factorial over 3 factorial times 1 factorial. So this is just going to be 4. That's what we got. And then this is going to be 4 factorial divided by this, or 4 choose 2. So that will be 6. And the last person is the same as the first person. That's also 4. But the thing is, with this multiplication, we just said the person A gets this, person B gets this, person C gets this. But we can actually swap those individuals as well. So since there is 3 people, so we can do this 3 factorial ways, or just 6 ways, but I'm going to write it 3 factorial for now. So this is my numerator. And denominator is kind of similar idea. But in this problem, like instead of kind of splitting those like colors into 3 different groups, like 4 by 4, just imagine there is no really like, there's no like those bars. So we have now like 3 reds. So just imagine these 3. And then we have 2 whites. So let's assume, okay, let's say we have 1 white and 2 white, which we don't see it, but I'm going to use that maybe green instead. So let's say this is white and this is white. And then we have 1 blue, which is I did already. And then 6 black. So we have 3 right here. And then I should have 1. So that's 4, 5, 6. So like imagine there's 12 tokens like this. And then I can rearrange all these tokens in any way that I like to. As soon as know how many ways can I arrange these, like 12 of these tokens, then I can just take the first 4 for the person A, next 4 for the person B, or next, like the last one is for the third person. So which is why the question is for us to answer how many ways can I actually arrange these 12 tokens. So just imagine like this way. So we have 3 R's. So R, R, and R. So we have 2 white. And then we have 1 blue. And then 6 black. So maybe black, I'm going to use L. So the question is, how many ways can I arrange this one? This is kind of the same as this approach. So we have 12 letters. When they were different, we have this many ways we can arrange. But since we have some repetition, so we just need to fix that over counting by dividing by number of ways that we can arrange those when they were different. So 3 R's can be arranged like 3 factorial, 2 W will be 2 factorial, and then 1 is just 1 factorial, and then 6 factorial for this guy. So then the rest just our simplification. 12 factorial and 6 factorial will have the 6 factorial will be canceled, so that is at least somehow helpful. So let's write a bit more. So 12, 11, 10, 9, 8, 7. So after 7, I stop because 6 factorial will cancel with that 6 factorial. And then we have 3 factorial times 2 factorial. And then numerator is 6, 4, 4, and 6. So 6 and 2 will cancel this one, which is good. And then we have like 36. I can cancel with them. That's going to be 4 left over. So I can cancel this 4 by this, which is going to be 2. So then everything will be gone now. So what we have now 4, 2, and this. So maybe I can divide this 4 by 4. So I can cancel one of these 2, and then one, like remaining 2, and then 1, 2 from here. So there should be 5 left over. So the numerator became just 4. And the denominator will be 11, 5, right? So there is 7 at the end. So that should be like 35 times 11. So that should be 4 over 385. So this is our probability for the given condition. So we have denominator is 385 and 4. So if you combine those, you get choice C. So again, this wasn't really a challenging problem. We've seen a lot of similar questions to this one in the past years, even in like this year's AMC 10 version. I think there was a easier version of this. So I'll attach some of those videos in the description so you can take a look at those to kind of do a little more practice. But I think this was fairly easy, I guess, for number 16 for the 12. Anyway, I'll see you in the next video.